Hello, welcome back to Algebra. In this lesson we're going to talk about parallel and perpendicular lines. Now all of you know what parallel lines are, and all of you, well most of you probably know what perpendicular lines are. We'll talk about what that means, but essentially parallel lines are lines that go on in the same direction, never crossing each other. Even if you go to infinity, they never cross each other. So when we talk in algebra about parallel and perpendicular lines, what we really mean is we want to write equations of lines that are perpendicular or that are parallel with one another. So I might give you an equation of a line, you know it's going to form some line on the graph, and then I might ask you to write an equation of another line that's parallel to the first one. And so we're going to go through exactly what parallel and perpendicular means and how to write equations of lines that are parallel and perpendicular. What you'll find is it's very simple now that you already know how to write equations of lines. So first of all, to get the ball rolling, I want to just say in general, we might have line number 1, I'm going to call it L1, and the equation of that line might be y is equal to m1x plus b1. Now you might say, why is he writing the number 1s here? It's just because it's line number 1. So I'm going to have line number 2 in a second. But anyway, line number 1 has a slope, whatever it is, called m1, and it also has some y-intercept, whatever it is, called b1, right? Now, you might also have a second line, which in a minute we're going to talk about if it's parallel or perpendicular to the first one. And line 2 might be y is equal to m2 times x plus b2. So you see, all I've done, and I haven't given you any numbers because I'm just trying to tell you that I have two lines, number 1 and 2, and each line has a totally separate and different slope from one another, m1 and m2, and a different y-intercept. You all know that. Different lines can have different slopes, and different lines can have different y-intercepts. So let's move along and talk about, now that I have this stuff on the board, what it means to be parallel and perpendicular lines, right? So we can say that line number 1 is parallel. This symbol means parallel, because writing the word parallel out is a real pain. It's parallel to line 2 if and only if slope of line 1 is equal to slope of line 2. That's basically all you need for lines to be parallel to one another. So first of all, let me talk about a couple of things. We have this phrase, if and only if. When you see if and only if in any math class, calculus, algebra, geometry, any of it, if and only if means it's what we call a necessary and a sufficient condition for whatever you're talking about. So in this case, you can replace this with line 1 is parallel to line 2. If and only if, meaning it's a necessary and sufficient condition if the slopes are equal. That's a big fancy phrase that just means all you need to look at is the slopes. You don't need to look at any other necessary and sufficient condition. It just means you don't have to look at anything else. You don't care about the y-intercepts. You don't care about anything else about these lines. The only thing that matters is the slopes of the lines. If they're equal from line 1 to line 2, then you have parallel lines. And that's not too hard to understand when you really think about it, because if you draw a quick little graph, I'm not going to draw a fancy graph on the other side of the board, but if here's x and here's y, then I can draw a line anywhere, right? Here I'm going to call it L sub 1. Now, it has a slope, right? M1, whatever it is, it has some slope. But if the slope of a second line called M2 is exactly the same as the slope of the first line, then that just means that the lines will never intersect, because what is slope? It's rise over run. So if the rise over run of this line is exactly the same as the rise over run of this line, then that means that they're tilted in the same way and they go up in the same direction, but they will never ever cross, because no matter how far you go out, the slope of this line is exactly the same as the slope of this one. So I could have told you that in the beginning. Hey, two lines are parallel if they have the same slope. That's all that you basically have to look at. So if I give you an equation of a line and I say, hey, write an equation of another line that's parallel to the first one, then all you really have to do is find the slope of the first one, and then you write the next line or whatever it is. You just have to make sure that it has the same slope. It doesn't matter what the y-intercept is. That's why you see the necessary and sufficient condition doesn't involve the y-intercept at all, because I can take L1, notice my pen is in the same slope orientation as this. I can move it up here, that's a different y-intercept. I can move it down here, that's a different y-intercept. I can move it over here, that's a different y-intercept. But as long as the slope is the same, you see how my pen has not changed orientation as has not changed the slope as I move it around the board. Anywhere I move some other line, as long as it has the same slope, will always be parallel.